This is the Chapter 10 test review for the pre-calc regular class. Number 1 on the review packet says find the distance and midpoint between 1, -6 and -3, -4. So just to kind of get a sense of what's going on, if I draw a little coordinate plane, 1, -6 is here, and -3, -4 is down here. So we want to find the distance and the midpoint between those 2 points. We have formulas to help us out. The distance formula, which is just a revision of the Pythagorean theorem, is x2 minus x1 squared plus y2 minus y1 squared. I like to call the first ordered pair x1, y1 and the second one x2, y2. That helps me when I plug numbers into a formula. So when I go plug my numbers into the formula, I'm going to get -3 minus 1 squared plus -4 minus -6 squared. When using this formula, please watch out for your double negatives. So -3 minus 1 is -4, and -4 minus -6 is +2. And then -4 squared, is 16, +16. I don't even need the parentheses. And 2 squared is 4. So I end up with the square root of 20. The square root of 20 is approximately 4 point something. And the reason that I know it's 4 point something without putting it in a calculator is because 4 squared is 16 and 5 squared is 25. So the square root of 20 has to be between 4 and 5, probably a little bit closer to 5. We could simplify that radical. We simplify it. There are a couple different ways. You learned how to simplify this. This is the way I prefer. I like to rewrite it as 4 times 5 because the square root of 4 is 2. So the distance is 2 square root of 5. Now the midpoint formula. The midpoint formula is just the average of the x values and the average of the y values. So you just add the x's, divide by 2, add the y's, divide by 2. And the midpoint is an ordered pair because it's a point. It's whatever point is smack dab between those two on a line segment drawn between them. So 1 plus -3 divided by 2 and -6 plus -4 divided by 2. I'm going to get -2 over 2, and I'm going to get -10 over 2, so it turns out that the midpoint is at -1, -5. Problem number 2, determine whether the points A at -5, -2, B at 3, 4, C at 10, 3, and D at 2, -3 are the vertices of a parallelogram. Justify your answer. The reason it says justify your answer is because it's not acceptable to just draw a picture and say yes or no. There must be some other way of determining if it makes a parallelogram. So think about what a parallelogram is. A parallelogram, opposite sides are parallel, opposite sides are congruent. So you could find the slopes of the opposite sides and see if they're the same. You could find the length or distance of the opposite sides, see if they're the same. But there's another way of determining if something is a parallelogram or not. If the diagonals of the parallelogram have the same midpoint, in which case they bisect each other, it's a parallelogram. So one of the things I'm going to do is I'm going to draw a quick sketch just to kind of see what it looks like. It's not going to be great, but it's going to sort of give you an idea. So -5, -2 is over here. 3, 4 is here. 10, 3, let's see, 4, 5, 6, 7, 8, 9, 10, 10, 3 is here. And 2, -3 is here. And And here is what I hope to be a parallelogram. All right, so we're going to find the midpoint of each of those diagonals. If the midpoint's in the same location, then it bisects each other, and if the diagonals bisect each other, it's a parallelogram. So the reason I drew a picture is because I wanted to know which segments I was going to find the midpoint of. We're going to find the midpoint of B and D, so I'm going to do that first. Remember, the midpoint is add the x's, divide by 2, add the y's, divide by 2. It's the average of the x's and the average of the y's. So 3 plus 2 over 2 and 4 plus negative 3 over 2 is going to be 5 over 2 and 1 over 2. So that's the midpoint of BD. Now I'm going to go find the midpoint of AC. So it's negative 5 plus 10 over 2 and negative 2 plus 3 over 2. I'm going to get 5 over 2 and 1 over 2. And look, the midpoints are at the same location. That means they bisect each other, and that means that this is a parallelogram. Number 3, write the equation of a circle whose diameter have endpoints at 3, 6 and negative 1, 0. In order to write the equation of a circle, we're going to use this formula. X minus h squared plus y minus k squared is equal to r squared, where h comma k is the center of the circle and r is the radius. Well, I only know the endpoints of the diameter, and you know on a circle, the diameter is a segment that goes through the center of the circle and cuts the circle in half. I'm not even going to put this on a coordinate plane because it makes no difference. I'll call that negative 1, 0 and 3, 6. In order to find the equation of the circle, the first thing I need to find is the center. The center is the midpoint of the endpoints of the diameter. So let's use the midpoint formula to find the center. The midpoint is going to be at 3 plus negative 1 over 2, 6 plus 0 over 2, which is 2 over 2, 6 over 2, which is at 1, 3. So now I know what h and k are. Now I'm going to go find the radius, because this is the best way to do it. Now, one of the ways you could find the radius is you could find the length of the diameter by finding the distance and then dividing that answer by 2. However, you're more likely to get a more reduced answer if you first find the center of the circle and then find the distance from the center to either endpoint of the diameter. So I am going to find the distance now from 1, 3 to 3, 6. The only reason I picked 3, 6 is because they're both positive. So the distance formula, I'm going to subtract the x's and square them. And then I'm going to subtract the y's and square them. So I get 2 squared plus 3 squared. That's 4 plus 9, which is the square root of 13, which cannot be reduced. So the equation of the circle is going to be x minus h is 1 squared plus y minus k is 3 squared is equal to the square root of 13 when you square it. Because squaring and square rooting are inverse operations, they end up canceling each other. So we would just write that it's equal to 13. Problem number 4 asks us to write the standard form of the circle x squared plus 14x plus y squared plus 6y equals 23. Standard form is the same thing as that factored form. So what we're going to do is we're going to start by creating parentheses that just have the x's in them. And then we're going to create a perfect square trinomial, because the perfect square trinomials always factor into something squared, which is what I want in my final answer for the circle. We're going to do the same thing with the y's. We're going to put the two terms with y's in their own parentheses with a blank. Now, the rules of algebra say you can add new numbers to an equation all you want, as long as you keep the equation balanced. So if we add two numbers to the left, we're going to add two numbers to the right. To determine the number that fills in the blank, you take the middle term, divide it by 2, and then square it. 14 divided by 2 is 7. 7 squared is 49. So that's the number that goes in the blank in the perfect square trinomial, and it also goes in one of the blanks on the right-hand side. The number that fills in the next blank. 6 divided by 2 is 3. 3 squared is 9. Now that we've created our perfect square trinomials, now we're going to write these in factored form. Remember I said in factored form, they're going to be something squared. You can do the factoring the old-fashioned way, which is what two numbers multiply to give you 49 but add to give you 14. Well, you're going to get 7 and 7. So it factors into x plus 7, x plus 7. But that's the same as x plus 7 squared. So the second perfect square trinomial is going to factor into y plus 3 squared. And 23 plus 49 plus 9 is 81. And now I've written my equation of the circle. Problem number 5, find the coordinates of the center, foci, and vertices of the ellipse x minus 5 squared over 16 plus y minus 2 squared over 36 equals 1. Now, I don't ask you to graph this, although drawing a quick sketch might help you out a little bit. One of the things you can do is when you will have all the formulas for all the conic sections. So on your ellipse formula sheet, you want to determine which set of definitions to use. And the other way of doing this is to draw yourself a quick sketch. So if you know where the center is at HK. Well, H is 5 and K is 2. So I'm going to start by drawing myself a little picture here. So 1, 2, 3, 4, 5, 1, 2. Here's the center. And then the square root of the number under the term with x, which is 4, says that there is a point 4 units to the right of center and a point 4 units to the left of center, and those are vertices. The square root of the number under the y term is going to tell you how far to put a point above and below center. So the square root of 36 is 6, so you can put a point 1, 2, 3, 4, 5, 6 above center, and 1, 2, 3, 4, 5, 6 below center. So there, if I draw this picture, I can see where the vertices are at. But I can also see how the ellipse is elongated, so that kind of helps me out when determining my vertices, and it tells me how to determine where the foci are at, because this is going to be the major axis. It's going to be the longer one. So the vertices, according to my definitions, if you don't want to draw the picture, are at, so this would be a squared, this would be b squared, if you're using the definitions to do this, which I don't think that's the best way to do it. I think the best way to do it is to draw a picture and determine where the vertices is at. But if you are using the definitions, this is how it will work. The vertices, we say, are at h plus or minus b comma k, and at h comma k plus or minus a. A is always the bigger of the two numbers. B is always the smaller one. For ellipses, this is not true for hyperbolas. So the vertices are going to be at 5 plus or minus 4 comma 2. So they should be at 9, 2 and 1, 2, which is where they're at. This is 9, 2, and this is 1, 2. And the vertices of the major axis are going to be at 5 comma 2 plus or minus 6. So they should be at 5, 8, which is where this one's at, and at 5, negative 4, which is where this one's at. Then the foci. You have to know how the ellipse is elongated because how you're going to find the foci depends on how it's elongated. Since it's elongated vertically, the foci are going to be at h comma k plus or minus c, where c squared is equal to a squared minus b squared. So a squared is 36, b squared is 16, 36 minus 16 is 20, so c is the square root of 20. You can leave it as the square root of 20. If you want to write it in simplified radical form, it would be 2 square root of 5. So the foci would be at 5 comma 2 plus or minus the square root of 20, or plus or minus 2 radical 5. Number 6, write the standard form of the ellipse, 4x squared plus 25y squared minus 24x plus 50y equals 39. All right, we're going to do the same thing we did with a circle. We're going to start by putting the x's together in their own parentheses, and then the y's together in their own parentheses. And since we're adding 2 new numbers to the left, we're going to add 2 new numbers to the right. The difference in this problem, though, is you cannot create a perfect square trinomial unless the leading coefficient of the trinomial is 1. So we're going to factor out whatever the leading coefficient is. So in the first one, we're going to factor out a 4, which is going to leave me with x squared minus 6x. In the second parentheses, I'm going to factor out a 25, which is going to leave me with y squared plus 2y. Now we're going to complete the square. So in the first parentheses, 6 divided by 2 is 3, 3 squared is 9. In the second one, 2 divided by 2 is 1, 1 squared is 1. But that's not what we're going to put on the other side. Remember, we factored out a 4 from the first parentheses, so we really divided this by 4 as well, even though we didn't know what the number was. So in order to account for that, we multiply it back in. So 4 times 9 is 36. 25 times 1 is 25. Now I'm ready to write this in factored form. So the first parentheses is going to be x minus 3 squared. The second trinomial is going to be y plus 1 squared. And 39 plus 36 plus 25 is 100. The last step is we want the equation to equal 1, so we're going to divide everything by 100 and reduce those fractions. 4 over 100 reduces to 1 over 25. 25 over 100 reduces to 1 over 4. And this is the equation of the ellipse in standard or factored form. Number 7, find the coordinates of the center, foci, vertices, and the slopes of the asymptotes of the hyperbola x squared over 25 minus y minus 3 squared over 16 equals 1. Again, I think it kind of helps a little bit to sort of draw a sketch of what's going on. So the center of this particular hyperbola is going to be at 0, 3. Remember, if there's no parentheses, it's really the same as this. So if I draw myself a little sketch, 0, 3 is right there. Because x comes first, the hyperbola is going to open left and right. How it opens depends on which variable comes first. So if it opens left and right, that means to find the vertices are going to be left and right of center. How far left and right? Take the square root of the number in the denominator. And the square root of 25 is 5. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So the vertices, I can tell by the picture, are going to be at 5, 3 and negative 5, 3. However, according to the definition, they are going to be at h plus or minus a, comma, k. So they're at 0 plus or minus 5, comma, 3. To find the slopes of the asymptotes, there's going to be a point 4 units above and 4 units below, 1, 2, 3, 4, that we make this little box, and then the asymptotes are the diagonals of that box, and that's how we draw the picture of hyperbola. So according to the definition, of hyperbola that open left and right, the slopes of the asymptotes are the square root, plus or minus b over a. Well, b is 4, not 16, and a is 5. So those are the slopes of the asymptotes. And if you're not sure, if you come back to the picture here, you have to go up 4 to the right 5 to get to the next point on the asymptote line. Then to find the foci are going to be at h plus or minus c comma k, where b squared is equal to c squared minus a squared. So 16 is going to equal c squared minus 25. 25 plus 16 is 41. And so c must be the square root of 41. So the foci are at 0 plus or minus the square root of 41, comma 3. Number 8, write the standard form of the hyperbola x squared minus 4y squared minus 16y equals 20. So when dealing with a hyperbola, one of the square variables is positive and one of them is negative. You want the positive one to come first. So we're going to make x squared first. The thing is, there's an x squared, but there's no quadratic term, or there's no linear term. I can't complete the square unless I have a quadratic and a linear term. So we're not going to complete the square on that, but we do have a quadratic and a linear term for the y's. So we are going to complete the square on that. So we're actually only going to add one new number to this equation. So I'm going to only add one new number to the right. Now the same rules apply as with ellipses. We're going to factor out a negative 4 because we can only complete the square when the leading coefficient is 1. So I'm going to get y squared plus 4y. Do you know why I got a plus 4y? Remember, we were dividing these both by negative 4, and two negatives make a positive. Now I'm going to complete the square. 4 divided by 2 is 2. 2 squared is 4. But the number that goes on the other side is going to be negative 16 because you have to multiply these. If this makes you feel better, I'm going to write this as x minus 0 squared minus 4y plus 2 squared is equal to 4. And then we have one last step, which is to divide everything by 4. The first fraction is still going to remain as 1 over 4, so it's going to be x minus 0 squared over 4 minus y plus 2 squared over, 4 over 4 is 1, equals 1. We don't normally write y plus 2 squared over 1, but I like to leave it in the equation because it helps me out when I'm graphing. Number 9, find the coordinates of the vertex and focus and the equations of the directrix and axis of symmetry for the parabola y plus 2 squared is equal to negative 16, x minus 1. First, when you do this problem, I want you to determine which type of parabola you're looking at. Well, we must be looking at the one that opens left or right. So the vertex, like the center of a circle, ellipse, or hyperbola, is at HK. H is always in the parentheses with x, y is always in the parentheses with k, so it doesn't matter what order it's written in. So in this case, h is 1 and k is negative 2. Remember, if you're having trouble determining h and k, you can always set your parentheses equal to 0 and solve for the variable, and that'll tell you the sign of your term. The next thing we're going to find is the axis of symmetry, because once you actually know the vertex, you can find the axis of symmetry. For a parabola that opens left or right, the axis of symmetry is going to be y equals k. So it's y equals negative 2. Then, in order to find the directrix and the focus, we need to know what p is. So we know 4p is in the same place as negative 16. So p must be negative 4. The definition for the focus, if the parabola opens left or right, is at h plus p comma k. So it's going to be 1 plus negative 4 comma negative 2, which is negative 3, negative 2. And the directrix is going to be the equation x equals h minus p. So it's going to be x is equal to 1 minus -4, which is x equals 5. Problem number 10, find the equation in standard form of x squared minus 6x minus 4y plus 1 equals 0. So even though I didn't say what type of conic it was, it's a parabola because only one of the two variables is squared. So if you know which variable is squared, that's the one you're going to complete the square on. Anything else goes on the other side of the equation. So I'm going to move that -4y to the other side. It becomes positive, and the positive 1 becomes negative. And since we're adding a new number to the left-hand side of the equation, we're going to add a number to the right. So the number that completes the square is 9. So in factored form, this is x minus 3 squared is equal to 4y plus 8. But it's not quite in standard form yet. I need to do one additional thing, which is on the right-hand side, I need to factor out what's in front of y. Now it's in standard form. X minus 3 squared is equal to 4 quantity y plus 2. And that is the material on the Chapter 10 test for pre-calc regular.